So this is our heart dissection with
Alice, Portia,
and Mia. Alright, so now we're going to go over blood flow of the human heart. So, deoxygenated blood comes in through the superior vena cava and the inferior vena cava into the right atrium, which is located over here, and then travels through the tricuspid valve in this area to the right ventricle, and then through the pulmonary valve it travels to the pulmonary artery, which is located over here. So it passes behind and then into this artery, and then out to the lungs. And the deoxygenated blood travels to the lungs, and then it becomes oxygenated, and then it travels back down into the left atrium, and then down to the left ventricle through the bicuspid valve, and then from there it travels to the aorta, and in the aorta it travels through the aortic valve to the aortic arch, and then the aorta extends all the way down to the abdomen, to the abdominal aorta, and from there it can travel to the upper body or the lower body, and it travels to every area of the body except for the respiratory zone of the lungs.
So now we're going to talk about some of the structures of the heart. So the first one is the interventricular septum, which is this structure right here. So the interventricular septum consists of two parts. The posterior region is thinner and more fibrous, whereas the larger part is thicker and more muscular in order to separate the right and left ventricles, which are these structures right here. The septum has a convex curve in order to accommodate the shape of the right ventricle. So the next part is the inferior vena cava, which is the structure right here. So the inferior vena cava is a vein, and it is inferior to the right ventricle of the heart. Its walls are thin in order to accommodate the low pressure from the blood, but it has a wide diameter, making it the human body's largest vein. Its function is to carry blood from the lower anatomy, so to go through here, and it goes into the right atrium. Valves within the vein help skeletal muscle contractions and abominable pressure pump the blood to the heart in order to reject the force of gravity, as it has to travel upwards into the atrium.
Structure we're going to talk about is the mitral valve. The function of the mitral valve, or the bicuspid, is to allow the blood to flow from the left atrium into the left ventricle. The mitral valve has two leaflets which allow for the blood to flow. So when there's pressure from the blood flow, it forces the leaflets to open so the blood can move from the left atrium into the left ventricle. And between the heart beating, the leaflets close up and they're tightly sealed so that it closes off the left atrium, which is carrying oxygen-rich blood from the left ventricle. And then the next structure is the left ventricle, and when the heart contracts, as I said before, the blood flows into the atrium and then through the mitral valve and enters the left ventricle, and the left ventricle pumps the blood out through the aortic valve into the aortic arch and into the rest of the body. And so here you can see that the left ventricle, the walls of the left ventricle are much thicker and muscular than the walls of the right ventricle, and this is because the left ventricle has to be powerful enough to distribute blood to the rest of the body and all the tissues.
So this is the aorta, and it originates from the left ventricle of the heart, and it distributes oxygenated blood to the rest of the body. So the aorta is a relatively long and wide artery, and it extends actually past the aortic arch all the way down to the abdomen. This is essential to its function because the aorta supplies all systemic circulation in the body, which means that it provides blood to all parts of the body except for the respiratory zones of the lungs. The aorta is also able to expand as the left ventricle contracts, which gives potential energy to maintain blood pressure while the aorta passively contracts. So the elasticity and elastic recoil help to conserve energy and smooth out the pulsatile nature created by the heart. So there's smooth blood flow throughout all of the circulatory system.